So this is part 2. I write the part 2 on here so that when Mrs. Navickas uploads it, she'll see. That way we can keep track of which ones are which. But I think we did finish the fruit fly example. So we'll do some more of these.
So what's going on?
What's going on with what we're going to do?
Yeah.
The ratio of carbon-14. Let me find my notes here. Give me a second to turn there. What's that? Yeah. I'm just going to finish going over what we didn't get to yesterday. And then we'll go over some of the homework, and then you can finish tonight what you didn't finish. Fortunately, we are way ahead, so.
Oh, really?
Yeah, I mean, I think so. From where they were last year.
What? No. That's
Oh, no.
a lie.
Well, in time, I mean,
Class?
if the dates on the tests were an indication, I don't know. But
You didn't take the same test that they took.
no.
Oh, well, that's true.
We're doing
Hey,
great.
Mr. Vickus, is there a chance I could like use a computer somewhere? I have to use it for like real quick.
For what?
A Bible quiz. That's all the computers, but
A Bible quiz, you mean you don't have your verse memorized?
no, it's like it's not a computer. Mr. Lovemark has
Oh,
like
it's
this.
like the multiple choice thing?
Yeah.
I know what you're talking about, yeah.
Yeah.
Those are awful, but.
Are you in study hall right now?
Yeah.
Well, yeah, you're gonna have to come back here and get one.
I'll be right back. I just want to make sure, so I'll be right back.
All right, so the ratio of carbon-14 to carbon-12 in a newly discovered fossil is R, which is just the ratio.
Okay.
Just reading the problem so far, Ben. Ratio is, and again, the starboard doesn't do really well with fractions. So what do you have? The ratio is 1 over 10 to the 13th power.
I'm following.
Okay? That's the ratio of carbon-14 to carbon-12 in a newly discovered fossil. I'm sorry, newly discovered. The formula that denotes the ratio of carbon-14 to carbon-12 present at any time in T years is R equals 1 over 10 to the 12th times E to the negative T divided by 8, 2, 6, 7. So this is what the ratio is. That's the model for the ratio at any time. And so it wants to know of this new fossil. This is the ratio here of the new fossil. And it wants to know what's the age of the fossil. Okay? So what are we going to do first?
Substitute in.
Right, substitute in R. That's good. That always tells you what R is in the new
No,
one.
I know, I
And
just.
that's R in the model. So 1 over 10 to the 13th equals 1 over 10 to the 12th E minus T over 8, 2, 6, 7. Okay? So substitution, that's a good first step. Now what?
Divide 1 over 10 to
Say that again?
12. Divide 1 over 10 to 12.
Divide. Multiply by 10 to the 13th?
No.
In that case, multiply by 10.
Oh, you wanna do
To
this?
get rid
Oh,
of
this
it.
one over here. I'm sorry.
Yeah.
Yeah, that is easier because
So
subtraction
then
is
you'd be
easier.
forced-
multiplying
get the-
10 to the 12.
That's easier.
Yeah, whatever, because then you're going to invert.
You're just multiplying it by this number here.
Yeah. That's what
Okay.
I meant, like invert.
Okay.
Like whatever.
So over here you get what?
10 to 12 over 10 to the first. 10 to, no.
That's
Yes.
over 10 to the 13.
10 to the negative
10,
1.
10 to the 12 over 10 to the 13. But what is that?
10 to the negative 1.
Which is,
1/10.
right, 1 over 10.
Oh,
Whoa.
Right?
yeah.
Okay. And that is equal to,
E.
well, there's one less, so this E to the negative T over
Are we
8, 2.
Are we trying to find T?
LN. Yes, we are trying
Yeah.
to find
T is the age of the
Okay.
fossil
Oh.
in
yes.
years.
So yeah.
T
she's
is in
right.
years.
Oh.
Okay? Now what?
So then you can't slide the
Take the natural log of each side. So the natural log of 1/10 to the natural, well, we don't need to write that, right?
Can't do it in the browser.
Save a step. Oh, I can go it does that. ln 1/10 equals negative T over 8, 2, 6,
Multiply
7.
it by 8.
6, 7.
Negative. Oh, yeah. Just 8, 2, 6, 7. Well,
Yes, yes.
yeah, just do what you're doing.
Then what?
Negative 1. I was correct. Could have multiplied it by negative 8267, right?
Let me go grab my calculator. So then do your calculator real quick and get an answer in years, and I'll grab my calculator.
Ben, guess where your calculator is?
Where?
I found it in my mailbox this morning.
Someone found it in school and put it in your mailbox.
Did they really?
Yeah.
People really care about me.
Well, don't jump to conclusions.
Wait, how did you know?
There's apparently there's not a high street value for those.
Yeah, I guess not.
All right, let's.
See? Calculators? Yep,
I'll be back next time because I need help.
Yeah.
I thought you were supposed to walk.
Uh,
He kind of does what he wants.
hold up. That's telling me
Doesn't mean he doesn't need a wheelchair.
19,035.5 years.
And we don't do years in decimals. So what is the year?
So 19,035.
Yeah, and
That's a lot of years.
it is.
Yep,
Years
this one's
isn't
fine.
even that old, is it?
Well, apparently these fossils are. We're not going to debate evolution today. We're just going to do the problems.
No, I don't like that. I don't like that problem.
You don't know how to get on
That's what the math book wants.
I'll move it.
Okay.
That's
There is
what
some
I want.
medical.
Doesn't the math book care about what I want?
No, and there is some scientific debate
That's
whether
really
carbon-14 breaks down after 1,000 years
Here's what I
at a higher exponential rate,
I
which is
got
why
one.
Christians believe that this carbon dating is not as accurate as scientists would think. But that's not part of the calculus class. The calculus class is how many years they want. Pre-calculus.
This is pre-calc.
They want us you to say
We're
19,000
doing
years
calculus?
because it asked to make sure. Estimate the age of the fossil, and it wants it in UT years. So you could have said yes. You could have said the 19,035 years. You would never have the decimal. But for fossils, the book says that you can estimate into the thousands of years.
Okay.
But that's not really that hard to do, though, right? You got the process isn't
You
bad,
did
right?
it, actually, yeah.
So I just have a quick question.
Okay.
Seeing as this is kind of referring to numbers 20 and 22 in the homework,
Okay.
is there a formula for this radioactive decay thing, or do I just have to wing it?
I didn't work it out, so I have to see.
Oh, well.
Complete the table for radioactive isotope.
Like, I know obviously there's got to be some sort of way to solve it because you have a variable, but I just don't know how to set it up.
For number 20, what's your variable?
The initial quantity?
Am I looking at the wrong page? Number 20 is the radioactive decay.
Yeah.
Or am I just...
So it's
I don't
two-
see the original quant. Oh, I see where it's just a gray box.
Oh, yeah, it's under the
Okay, I was looking for something else.
No.
Okay. So, do they want you to go back and, because you would need a formula, right?
Yeah.
Complete the table for the radioactive isotope.
What is that?
So am I supposed to like base it?
Well, if you look at 19 and 20, so they only want to, were both assigned in the homework?
Yeah, 20 and 22.
All right, so if you see number 19, you could find it by, it gives you the 10 grams in 1600 in the years after, although I don't know why it. So you'd have to do 19 and 20.
Oh, or aren't they gonna be the same? Or no?
Yes, but you're going to use one to substitute it for the other like we did before, remember? So they didn't assign 19, so that was the issue.
Huh?
Remember the first one we did yesterday with the fruit flies where we substituted in?
Oh, that was so
So
dumb.
22 can stand by itself though? Is it-
I have
But
to see.
carbon
Do they
is-
give you any sort of? They don't give you any information. I don't.
That's what I was really confused about. I mean, my book has something written in it, but I don't know what that is.
Let me look up and see
I
what.
could have done what you did.
Is it gonna be like one of the decay things or whatever? Like, so it's the graph decays? Is it exponential decay model? Is that what I'm using?
Yes.
Okay. I didn't put that together last night.
Yeah.
The y equals a e to the negative bx.
And
All right.
17.
Y equals a e to the negative dx.
The formulas I gave you yesterday, I gave you a bunch of formulas.
Okay.
You did.
Okay. How about this?
Yeah, it's bad.
On the Richter scale, the magnitude R of an earthquake of intensity I is given by,
What?
I'm just reading the problem.
Richter scale? Okay.
All right, is
Even problem.
the Richter scale R equals the logarithm base 10 of I over IO, where IO equals 1, and that's the minimum intensity used for comparison. Intensity is a measure of wave energy of an earthquake. Okay? So this is how they measure earthquakes intensity, and it's done in factors of 10. Okay, if you didn't know that. So when you have something that's on a Richter scale 3 and something's a 4, the one that's 1 more is 100 times more intense, not 1 more intensity. So they do that exponentially. That's how earthquakes are measured. Okay, so here's our problem. In 2001, the coast of Peru, and some of these questions really, I think, I'm finding that in Algebra 2, they assume that you know certain things about science going in. They ask these problems a lot about headwind and tailwind, and if you really don't know what that means, it's really difficult to solve the problem. So that's why I kind of give you a little heads up on what this Richter scale is all about. And so they measure that intensity of an earthquake exponentially. Okay. Anyway, in 2001, the coast of Peru experienced an earthquake that measured an 8.4 on the Richter scale. In 2003, Colima, Mexico experienced an earthquake that measured 7.6 on the Richter scale. Find the intensity of each earthquake and compare the two intensities. All right, well, this is, finding the intensity is not that bad, right?
Okay, so
What would you do for the first one? Let's find the first one, the Peru. Let's find the Peru intensity.
R equals base.
8.4.
8.4.
Oh.
I told you, right? 8.4.
Right, sorry.
All right.
Equals log base 10
Log 10.
I over 1.
Okay.
Take the log of. No, 10. Wait.
Multiply by 10. Yes. Multiply by
10
10.
to base. 10 to base. 10, 8 point. Yeah!
Oh, okay.
I did do something right. And then you're going to be left with 10.
We can just change that to I, right? Because of I over 1.
Yeah.
And you're left with what?
This is definitely my cap.
8 point. Oh, I'm sorry. 10.
Whoa.
4 equal
I.
It was a
equals
big number.
I. So all you had to do was take
But 10 to the 8.4 equals a lot.
the
If you made E to the 8 thingy, whatever E is, I don't like those.
Give me 2.51189E8.
Yeah, that's what I got.
Okay.
What is that?
I don't know what that means.
Yeah,
What does
but
what mean?
The E thing.
What does
That's
any of
10 to the 8. It just means that there's 10 spots there.
What?
When your calculator says that, so in other words, your answer is
There's 10 spots in
2,
between.
5, 1, 1,
Come back.
8, 9.
8, 9, and there's 8 spots. So 1, 2, 3, 4, 5, 6.
When do you want me to come?
Did I get 8? Oh, the 2 doesn't count. There's 8 decimals. 1, 2, 3, 4, 5, 6, 7.
What's
Sorry.
your say? Your seat?
251.
Oh.
251.
Million?
Huh?
Million.
Million.
189,000.
Trillion, zillion, billion.
That's your number. That's the intensity of the Peru earthquake. Is 251 million.
That's
Okay.
pretty
Yeah, I'll be in
intense.
here tomorrow.
Yeah. And so keep in mind, right? What's the worst earthquake you could have? 10. Although you could never really reach 10. You can get really close. That's the speed limit. That's the upper limit of an earthquake. If for intensity on the Richter scale is 10. So you're pretty close. So that Peru is a pretty bad earthquake. That ain't no shaking and baking there. All right. So let's see. All right. It's easier to erase so you can still see the numbers.
Wait, don't we need that for something then?
Yeah, you need that other number.
Need what other number? Now they want to know the intensity of the one in Colima, Mexico, right?
Compare the two. Okay, I got
So
it.
7.6 equals. I can scroll this back down now. Sorry. And
Base 10.
log 10
Okay.
of I. Okay.
raise to 10.
So 10.7 to the 6 equals I. And so if you do that on your calculator, you'll find out what the intensity was in.
3.98107, and then we'll have 2 zeros after it. So
Why do they even have to put that in there?
39
It's just 2
million.
zeros because then it's like not significant figures.
If what?
Why do they have to tell me that there's 2 zeros after that? Because
2 zeros after what? I'm confused.
3.9810700.
Mine doesn't say 0, 0. Mine is even 7. There might be a 7 that you
Yeah.
have on there.
It says E to the 7th, but I'm saying if there's 7.7.
Oh, instead of writing the E at all, just writing the numbers all out? Is that what you're saying?
Yeah, but if there's 2 zeros, then why do they even have to put that in there? Because it's significant figures. These are the questions that haunt me. It probably doesn't even have an answer, so we don't have to go there.
It's 39 million is the intensity. So you're saying that you want them to just write that number on your calculator?
No, I don't
Yeah.
think they have to put in the E to the 7 thingy.
What else would you do? You can't leave it 39,000 something. 390,000. If you add the zeros, then that's a much different number, right?
Yeah, sure.
Well, there's a difference between 39 million and 380,000, right? So one's a whopper of an earthquake and one's a little tremor. All right. So so now we know. Now you know.
Math humor.
I don't understand the E thingy.
Okay.
I mean, I do now, but I don't appreciate it.
Okay. So now I want you to compare the two. So let's just compare the two. Did you write them down as we went?
Oh.
Yes, I have in my calculator.
What was the first one? 251 million something.
That one is way bigger than the other one.
Yeah.
189.
189,000.
Yeah.
By like a whole.
Okay. And what was the one in Mexico? Oh, I got it right
39.
there.
Oh yeah, you have that one.
And if you do a quick division, you can compare them. And what does that come out to? Oh, I forgot to mark decimal.
381.
Okay.
6, 1. No, 0. Wait, what did you get?
Whatever, I rounded.
It's not exactly 6. It's approximately 6.
What is that? What did my calculator not put in?
6.30959.
Yeah, but that put in something. Stupid calculator.
Did the calculator forget to do it, or did you forget to do it?
No, the
So
one
you got
line
about 6, right?
Yes.
So what is that telling you about the Richter scale?
That's an average of the two earthquakes.
Look at the two. It's not an average. No, absolutely not. So that's all right. Look, you got an 8.4 and a 7.6. So one is 0.8 higher on the Richter scale. So the Richter scale is a 0.8 higher, but the earthquake in, where was it, Peru? Is that what he said?
Yeah.
Peru is 6 times as intense as the one in Mexico. So you got 6 times, even though you have a 6 times more intense earthquake, your Richter scale only goes up by 0.8. So that's what I meant when I started from the beginning. I told you it's exponential, and it's based on a logarithm. It's not. A lot of people think if you have a Richter scale of 5 and a Richter scale of 8, one is like, or I'm sorry, let's say you have a Richter scale of 4 and a Richter scale of 8, they think one earthquake is twice as bad as the other. That's not the case. One is significantly higher, exponentially higher. Okay? So the Richter scale doesn't work on multiples, it works on exponentially. All right. That's not too bad. Did I have another? No. Okay. Let me stop the recording.